Assalamu alaikum class. Experiment number 12 of your practical notebook is to prepare 100 centimeter cube of 0.1 molar sodium carbonate solution. The solution we have to prepare in today's practical class is 0.1 molar sodium carbonate solution in a volume of 100 centimeter cube. Apparatus required are a measuring balance, a beaker having a stirrer, this volumetric flask, and a watch glass funnel. These are the apparatus. Chemicals required are sodium carbonate, distilled water. Now first of all we have to find the molar mass of sodium carbonate. The formula of sodium carbonate is Na2CO3. The calculations required to find the molar mass of sodium carbonate is: write down the atomic masses of all the elements in the formula, that is sodium, carbon and oxygen. The atomic mass of sodium is 23, the atomic mass of carbon is 12, and that of oxygen is 16, and multiply it along with the number of these elements present in the formula, and then add all these figures and we will find the molar mass of sodium carbonate. The number of elements present of sodium in the formula is 2, so multiply the number of 2 with 23 atomic mass of sodium, 1 with carbon as carbon is 1 in the formula, and 3 with oxygen's atomic mass as oxygens are 3 in the formula, and hence we get 106 gram, which is the molar mass of the sodium carbonate. Next, as we have to prepare the solution in 100 cm cube, so if we convert this 100 cm cube into a dm cube, as you can see, the formula for converting a centimeter cube into a decimeter cube is volume of solution in decimeter cube, 100 divided by 1000, and after calculation we will get the answer is 0.1. So by dividing 100 over 1000 we will get 0.1, which is now dm cube or decimeter cube. So we have converted the volume from 100 centimeter cube into a decimeter cube. Now next, the formula for molarity for finding a molarity of a solution is molarity is equal to number of moles divided by volume of solution. So if we could rearrange this formula for finding the number of moles, that how much number of moles of sodium carbonate will be required to make a solution of 0.1 molar, then as you know that we know the molarity, which is 0.1 molar given in the title. Volume of solution is also known to us, which is 100 decimeter cube, and number of moles we have to find from this formula. So we have to rearrange this formula and we will get the number of moles from this formula. As this is the general formula, but the substance here is sodium carbonate, so I'll write sodium carbonate, number of moles of sodium carbonate, which is equal to this formula I get by rearranging the upper one formula. So number of moles of sodium carbonate is equal to molarity of sodium carbonate multiply volume of solution. Molarity of sodium carbonate is given in the title, that is 0.1 molar, and volume of solution which we get in the upper calculation, that is 0.1 decimeter cube. So after multiplying I will put first of all I will put the values, that is molarity of sodium carbonate, which is 0.1 molar, multiply by volume of solution which we get, this is 0.1 dm cube or decimeter cube. Then I will multiply this 0.1 into 0.1. Now I'm calculating the values, that is 0.1 multiply by 0.1. The answer I will get here is 0.01 mole. Hence in this way we find the number of moles of sodium carbonate which is required for this solution formation. Next, a general formula is to find the number of moles of substance, which you have learned in the first chapter of chemistry. Formula is number of moles is equal to mass in gram by molar mass. So by rearranging this formula, we have to find the mass required in grams. Okay, as we have calculated the molar mass of sodium carbonate, that is 106 grams, and also the number of moles, which is 0.01 mole. Then after rearranging this upper one formula, number of moles equal to mass in gram by molar mass, we get this form of the formula: mass required is equal to number of moles divided by molar mass. In this way we will find the mass required to prepare this solution. Number of moles is 0.01 mole multiply, now I am putting the values, 0.01 mole, which we have find here. This is number of moles of sodium carbonate multiply by molar mass, and molar mass we find here, that is 106 grams. So I am putting the values of molar mass, which is 106 grams per mole. Now after multiplication of these two values, now I am multiplying these two values, 0.01 multiplied by 106, the answer I will get here is 1.06 grams. Now this 1.06 grams of sodium carbonate is required to add into this titration flask, and then in this way we will prepare 100 centimeter cube of 0.1 molar sodium carbonate solution. So these was the early calculations required to prepare 0.1 molar sodium carbonate solution in 100 centimeter cube. After these early calculations, we find that how many grams of sodium carbonate will be required to prepare 0.1 molar solution. Hence, in this way, we find that 1.06 grams of sodium carbonate will be required to prepare its 0.1 molar solution. Remember the formulas. Next procedure is we will take a measuring balance and calculate a proper amount of sodium carbonate, which we have to take 1.06 gram. How we find that 1.06 grams of sodium carbonate is required? From the early calculations which we done earlier in this video. Next we will add this 1.06 grams of sodium carbonate into a little amount of water. Take a beaker and add a little amount of water into this beaker. Add this 1.06 grams of sodium carbonate into the beaker, stir it well. Next step is that we have to add that saturated or concentrated solution into a titration flask. This is called as titration flask, which is of 100 centimeter cube volume. Pour this concentrated solution into this titration flask with the help of this glass funnel. Also wash this beaker and stir with the help of distilled water. There is no minimum amount of this sodium carbonate could lift in this beaker or along with this stirrer. Last step of this experiment is take water and fill this volumetric flask up to this mark, and in this way, by filling this volumetric flask up to this mark, we will prepare 100 centimeter cube of sodium carbonate solution, for which we add 1.06 grams of sodium carbonate into this 100 centimeter cube of water. Please make correction of the word titration flask. This is volumetric flask. Okay class, thank you.